our physical participant. We welcome you for this important lecture. Today we have a lecture from Dr. Haider Khwaja. He is from the Ministry of Albania, and he did a lot of work on environmental pollution and air pollution in different countries. And last time he has also completed one carried out courses in our institute. So I am on the behalf of director and on the behalf of iccbs, I am very much pleased to call upon Dr. Haider Khwaja for starting this lecture. Dr. Haider Khwaja, sir.
Assalamu alaikum. Can you hear me?
Yes, sir.
Okay. So, good morning, and here it's around 12:30 a.m. And today I'm going to talk about the link between climate change and health in reference to air pollution. So the presentation is about air pollution, climate change, and health nexus. Who cares? Greenhouse effect and global warming. Some recent and historical temperature trends. What are the possible consequences of global warming? What are the climate change and human health, the air quality impacts, and then the vulnerability to climate change in reference to Pakistan. So as you know that air pollution is a very major public health concern. It is a significant factor shaping public health in the developed and developing countries. Air pollution, as you know, is the second highest cause of deaths globally, trailing high blood pressure. The high blood pressure is top among the burden of diseases, and air pollution is the second highest cause of deaths. According to a recent report by Health Effects Institute last year, air pollution contributes to 7.9 million premature deaths, 275 million healthy life years lost, and it is burdening about $4.6 trillion annually. And if status quo, then according to United Nations Environmental Protection, this cost will be about 18 to 25 trillion dollars by year 2060. This burden is not uniformly distributed. About 90% of deaths, about 1 in 8 deaths and lost life years occur in the developing countries of Asia. In terms of global disease burden, air pollution is the cause of over one-third of deaths from stroke, lung cancer, and chronic respiratory diseases globally, and about 25% of deaths from ischemic heart diseases. Air pollution and climate change both are closely linked. Air pollution and climate change are two sides of the same coin. They are inextricably linked. The primary cause of both is the combustion of fossil fuels for energy, for industry, and transportation. Many air pollutants like carbon dioxide, methane, and nitrous oxide, they contribute to climate change by influencing the quantity of incoming sunlight which is reflected or absorbed by the atmosphere, with some pollutants warming the earth and others cooling it. Increased heat creates stagnant air and more frequent extreme weather events which prevent pollutant from dispersing and worsens air quality, for example, increased ground level ozone. Pollutants like black carbon, which is a component of soot, it mainly comes from diesel, and methane, they are potent short-lived climate forces that accelerates global warming. Black carbon increases warming by absorbing sunlight and accelerating the melting of ice and snow. Feedback loops like rising temperatures due to climate change increase the frequency of wildfires, which release massive amounts of stored carbon and pollutants into the atmosphere. There is a connection among air pollution and climate change and health. The sectors that produce majority of greenhouse gases are transport, as you can see on my left, the energy, industry, the land use, and the waste management. They are also the main sources of air pollutants like fine particulate matter, that is PM 2.5, and other key pollutants like black carbon, ozone, and NOx. For example, short-lived climate forcing pollutants, the SLCPs, such as black carbon, methane, ground level ozone, and sulfate aerosols. After greenhouse gas like carbon dioxide, these short-lived climate forcing pollutants, they damage human health and also the leading contributors to global warming over shorter time scales. Black carbon, which is a soot and which is a combustion derived particulate pollution, it absorbs solar energy and warms the atmosphere. It is accelerating glaciers in mountainous regions and the Arctic and disturbing the South Asian monsoon. Methane trap heat in the atmosphere, leading to global warming, and it is an important precursor of ground level ozone. Ground level ozone, that is in the troposphere, it acts as both a harmful pollutant as well as a potent greenhouse gas. It damages agricultural crops and human respiratory systems. Particulate sulfates, it serves to cool the earth atmosphere. So the million-dollar question is who cares? Climate change is the major global health threat of this century. So climate change, there was a survey which was conducted by the Pew Research Center in about 39 countries among 37,653 respondents from March 2nd to May 1st, 2013. And then this survey was again conducted in 2017 and in 2018. They found that public around the world are concerned about the effects of global climate change, particularly in Asia, Europe, and Latin America. Most importantly, people in Greece they express that very high levels of concern, as you can see on the right hand side, uh, about 90% labeling climate change a major threat. Since 2013, worries about the climate threat have increased significantly. As you can see, in 2013, the climate change concern was about 56%, and in 2018, it has increased to about 67%. So, what are the main greenhouse gases? Here I am summarizing some greenhouse gases. The first column, carbon dioxide, methane, nitrous oxide, some chlorofluorocarbons, perfluoromethane, perfluoroethane, and sulfur hexafluoride SF6. In the second column, I am giving you the pre-industrial concentrations in parts per million. That is way back in about 1850, and then the concentration in 2020 in parts per million, the atmospheric lifetime in years, and then the next column is what are the anthropogenic sources, and in the last column I am giving you the global warming potential. So our atmosphere contains moisture, that is water, and water vapor it is around 0 to 2%, and it is by far the most important natural greenhouse gas. The water is an important natural greenhouse gas. The next is carbon dioxide. It is the second most important greenhouse gas. Its lifetime is in the range of 5 to 100 years, and the main anthropogenic source is fossil fuel, combustion, cement production, land use conversion. The third one is methane, which is a reactive trace gas. Its lifetime is about 12 years. Main anthropogenic source is fossil fuel, rice paddies, waste dumps, and livestock. The next important greenhouse gas is nitrous oxide. It is greatly influenced by its production in the ocean. Its lifetime is about 121 years, and the anthropogenic source is fertilizer, combustion, and some industrial processes. The other less important greenhouse gases are chlorofluorocarbons, perfluoromethane, and sulfur hexafluoride. So these greenhouse gases are generally composed of molecules with three or more atoms. The most important thing is that they absorb infrared radiation from the Earth's surface, and they emit radiation from much higher and colder levels out to space. They do not absorb visible light. They absorb and emit only infrared radiation. These radiatively active gases are known as greenhouse gases because they act as a partial blanket for radiation from the Earth's surface, keeping the surface warm, and it is based on the idea that the gases trap heat like the glass walls of a greenhouse do. And this blanketing is known as natural greenhouse effect. So here I am showing you the greenhouse effect and global warming. Our sun, the solar radiation passes through the atmosphere. It has an intensity of 343 watt per square meter. Some of the solar energy will be reflected back into the space, and the remaining is absorbed by the Earth's surface, mostly in the tropical ocean. This incoming solar energy warms the Earth, which then emits energy mainly in the form of infrared or heat energy. And this infrared energy has a long wavelength. Greenhouse gases, unlike other gases, they have molecules which absorb and re-emit some of this infrared radiation. So some of these infrared radiation would be absorbed by these greenhouse gases, and some would be reflected back into the atmosphere. So the more greenhouse gases present in our atmosphere, the more heat will be absorbed and retained. And that is global warming. So here I am giving you an example of carbon dioxide. It has one carbon atom which is bonded with two oxygen atoms. It can absorb infrared red radiation, and the molecule starts to vibrate. This vibrating molecule will emit radiation, and that radiation will likely be absorbed by another greenhouse gas molecule in the atmosphere, and this absorption emission absorption cycle serves to keep the heat near the earth's surface, and that is insulating the surface from the cold or cold of the space. So here I am giving you the graph showing the global emissions of carbon dioxide by world regions between 1950 to about 2022. You should note here that the global carbon dioxide emissions have increased sixfold since 1950. In the 1950s, the United States and the countries later formed European Union were the biggest emitters in the world, greater than 70% of the total annual emissions. From 1950 to 2000, China witnessed a surge of about 4,500% increase in emissions, reaching an annual about 3.6 billion tons by 2000. Global emissions have increased from 25 billion tons in 2000 to about 37 billion tons in 2022. And today, over 40% of emissions come from US and China. So here I am showing you three graphs, and these three graphs show the changes during the last 1000 years, from year 1000 to year 2000. This bottom graph shows carbon emissions. The beige band shows emissions due to change in land use, and the pink band shows fossil fuel emissions. So fossil fuel emissions have increased dramatically since the Industrial Revolution around 1850. This middle beige curve shows atmospheric carbon dioxide concentrations going hand in hand with carbon emissions. The carbon dioxide concentrations before the Industrial Revolution were about 280 parts per million, but the current concentration is around 430 parts per million. And the top one, the pink line, shows that although there has been some variability, global average surface temperature has increased about zero point 0.7 degrees Celsius during the past century. Temperatures are now changing at the rate of 0.18 degrees Celsius per decade. Now, here I am showing you the trends in greenhouse gases for the last more than 1000 years. These data are from ice cores from Antarctica and Greenland. The newer data, that is from 1950s onward, are from Mauna Loa Observatory. These gases are very well mixed in the lower atmosphere. What you can see here that since the mid 1800s, that is after the Industrial Revolution, concentrations of carbon dioxide, methane, and nitrous oxide have increased by 50% for carbon dioxide, 150% for methane, and about 25% for nitrous oxide. And the main reason for these increases over time is the increase in their anthropogenic emission rates. Currently, we do not have the black carbon data so far back to 1000 years, but 90% of black carbon is anthropogenic in nature, and its main source is fossil fuels and biomass burning. Since mid 1800s, fossil fuel emissions of black carbon have increased. Now, what are the global warming temperature changes due to greenhouse gases and black carbon since mid 1800s, that is Industrial Revolution? As I said, that the water vapor is the major natural greenhouse gas. So in the first column, I am giving you water vapor as well as the other greenhouse gases. The third column is the current tropospheric concentrations. Then the fourth column is the natural percentage of current mixing ratio. The next column is anthropogenic percentage, then the percentage of natural greenhouse effect, and the last column is percentage of global warming temperature change due to each component. Now let's just concentrate on the last two columns. The most important natural greenhouse gas is water vapor, which accounts for 89% in the last column, the top one, of 35-degree temperature increase because of natural greenhouse warming. And carbon dioxide is the second important greenhouse gas, which accounts for about 7.5% of the natural greenhouse effect. This is the natural greenhouse effect. Now let's go to the last column. For near surface global warming, carbon dioxide is the most important greenhouse gas, which accounts for about 46.6% of such warming. Black carbon is the second important, which is responsible for about 16.4% of global warming today. And this global warming potential, it is an index defined as the cumulative radiative forcing between the present and some chosen time horizon caused by a unit mass of gas emitted now, and it is expressed relative to a reference gas such as carbon dioxide. So the natural greenhouse effect, water vapor is the major, contributes about 89% of global warming. Carbon dioxide contributes about 7.5%. However, the anthropogenic carbon dioxide is the major greenhouse gas, accounts for about 47%, followed by black carbon contributes about 16.4%. So, how the historical and recent temperature trends, how we record the temperature records. There are, if we really want to assess whether global warming is occurring, we should investigate our historical as well as the recent temperature trends of the earth. Historical temperatures have been determined in many ways. For example, I am showing here from the ice core analysis, from ocean floor sediment analysis, from the analysis of lake levels, from tree rings, rocks, pollen in soil deposits, pollen in deep sea sediments. So these are different ways by which the historical temperature records have been determined. So the recent trend in global average surface temperature, here I am showing you the recent temperature in global average surface temperature between 1850 to about 2024, and I have taken this from WMO. Now, all six data sets, there are six data sets, one from the headcruts, NOVA, the GISTEMP, Berkeley Earth, GRA, ERA 5, six different organizations. All six data shows evidence of global warming. So if we see the data of the temperature from 1850 to about 2024, we can see here that the temperatures were quite stable between 1850 and 1910, quite stable. Then gradually temperature increased from 1910 to about 1940. Then the temperatures were again stable from 1940 to mid 70s, but it increased rapidly from mid 1970s to 2024. Now, if we use the statistics from this linear fit, the rate of increase in the globally average surface temperature between 1850 to about 2024, the temperature increase is 0.0043 degrees Celsius per year. If we take the best fit from 1850 to 2024. But between, if we take the data from 1970s and onward, this temperature increase is quite significant. So the past 10 years from 2015 to 2024 are the 10 warmest years on record. 2024 saw exceptional land and sea surface temperatures and ocean heat. March heat waves in Antarctica produce the highest temperature excursion above normal ever measured anywhere on Earth. Droughts affecting Europe, China, and US Southwest, floods in Pakistan. So, from 1990 onward, there is a major temperature increase. So, here I am showing you the temperature increases. Some people argue that there is no global warming. So, in 1988, United Nations WMO and United Nations Environmental Protection Agency UNEP, they established a program called IPCC, that is Intergovernmental Panel on Climate Change. Since 1990, every 5 years they assess international scientific work on climate change, what are the potential impacts, and then they come up with some prevention options. Records show that climate is changing. Now, the next question is the degree to which human activities are responsible. So, here I am showing you two figures. The top figure shows the global surface temperature anomalies relative to the period 1901 to 1950. This black line shows the observation, and the thick red curve shows the means from the models. And here both the anthropogenic and natural forcings are included. So these vertical gray lines, they indicate the timings of major volcanic activities in the world. This bottom figure shows the global mean surface temperature anomalies relative to the period 1901 to 1950, and again black line shows the observation, the thick blue curve shows the mean from the models, and the thin lighter blue curves shows the model results. Here only the natural forcings are included. So it is very clear that the temperature increases cannot be explained by natural processes. So here another evidence, the left one 1984, the the right hand side 2019. Historically, the Arctic Ocean, it contains the oldest and thickest solid layer of frozen water in the world. And according to the research from American Geophysical Union, 95% of its mass is lost over the last 35 years. And if this trend continues, then summers in the Arctic Circle may be free of sea ice entirely by year 2030. So Arctic ice is melting. This is the evidence that global warming is occurring. So here I am showing you the projected changes in global temperature. IPCC predicts that over the next century, carbon dioxide concentrations will increase from about 355 parts per million in 1990 to about 540 to 970 parts per million by year 2100. And during the same period, the prediction is that the average global surface temperature will increase between 1.4 degrees Celsius and 5 degrees Celsius. So there is a prediction that between 1.4 and 5 degree Celsius increase in temperature by the end of the century. So how they predicted? There are different models, and it is based on four different scenarios. So as you can see here, four different scenarios. The topmost curve, that is the red one, it is by assuming the constant aerosol concentration beyond 1990 and a highest climate sensitivity of about 5 degrees Celsius. This lowest curve, the beige color, is by assuming constant aerosol concentration between 1990 and a low climate sensitivity of about 1.4 degree Celsius. These two middle uh, curves, the green one and the blue one, are the results with best estimate of climate sensitivity of about 2.5 degrees Celsius. The upper blue curve by assuming a constant aerosol concentration beyond 1990, and the lower curve by assuming increasing aerosol concentrations beyond 1990. So the main assumption here is that the greenhouse effect is reduced by increasing aerosol concentrations. Now here on the right hand side, I am showing you two panels. These central and the right panels are the projections of these values averaged over the decades 2020 to 2029, the center one, and 2090 to 2099, the right hand side. And it is very evident from these projections that the temperature will increase further in the coming decades by the end of this century. So now you know the climate change, what is greenhouse gases, what are the possible consequences of global warming. The climate change have wide-ranging impacts on the natural environment as well as on the human societies and economies. For example, the precipitation would increase, the sea level would rise, species and natural areas would be affected, coastal areas would be impacted, water resources would be impacted, forest, agriculture, and most importantly, human health. Now, to assess these direct potential impacts, it is necessary to estimate the extent and the magnitude of climate change, particularly at the national and local levels. Although we have made quite a bit of progress in understanding the climate system and climate change, but the projections of climate change and its impacts still have many uncertainties, particularly at the regional and local levels. So let me give you a few examples. The first one is the sea level rise. In globally, 13 of the 20 megacities of the world, they are located at sea level. The major impact of the sea level rise is the flooding of low-lying coastal areas and the elimination of the flatlands which are just above the sea level. As a result, freshwater aquifers will be salinated, and drainage and sewage systems will be disrupted. People would migrate from these areas. Refugees would suffer heavy health burdens, overcrowding, lack of shelter, and competition for resources. Now, here is an example for Bangladesh, one of the world's poorest and densely populated nation. It is at highest risk. This figure shows a three-dimensional view of the country with the current coastline and major rivers. Now, assuming if there were a 1.5 meter rise in sea level, then 17 million people would be displaced from their homes. In US, New Orleans, which is already below the sea level, it would similarly face a danger of flooding. And I think Pakistan is also would be affected because of flooding. This next example, I'm showing you the heat wave, and this I have taken from Robin papers in 2008. The excess mortality from 2003 heat wave in Europe, and that was in August. This table shows the mortality from the 2003 heat wave in Europe. The heat wave has killed more than 40,000 people in just 2 weeks in August, and more than 70,000 people overall. So just 2 weeks heat wave in Europe, more than 40,000 people died because of heat wave. Another example is the drought and food production for areas of the world that are already water constrained. Climate change will increasingly cause adverse impacts on agricultural production through diminishing water supplies, increases in extreme events like floods and severe storms, heat stress, and increased prevalence of pests and diseases. Here I am showing you the model prediction, and recent model study shows that by the end of this century, the average growing season temperatures will exceed the hottest temperatures on record from 1900 to 2006, and as a result, we will see reduced crop yields throughout the tropics because of the heat stress, and the crops may be damaged from flooding, erosions, and wildfires. Now, the next important is the urban heat island. This figure shows the urban heat island. As you know, the urban areas generate and retain heat because of the buildings, human and industrial activities, and many other factors. The black asphalt and other dark surfaces on roads, parking lots, and roofs, they will have a low albedo. Low albedo means the reflectivity. They will absorb and retain more heat and re-radiate it at night time. And also, in general, the urban areas generally lack trees, so they receive less of the cooling effect. Now, how does climate change affect human health? Here I am showing you the diagram the exposure pathways by which climate change affects human health. Here in the center, three boxes, they are the list of some examples of changes in climate drivers like increased temperatures, the precipitation extremes, extreme weather events, sea level rise. These are the climate drivers. Then the next box is the exposure pathways like extreme heat, poor air quality, reduced food and water quality, changes in infectious agents, population displacement. And then the last one is the health outcomes, the health related illnesses because of climate drivers, the exposure pathways, the cardiopulmonary diseases, the food, water, and vector borne diseases, and most importantly, mental health consequences and stress. So, some of the key factors that would influence the vulnerability of individuals are shown in this right box, that is the social and behavioral context like age and gender, race and ethnicity, poverty, education, and all these different factors. And then some of the key factors that would influence at larger scales, they are shown in the left box, that is the natural and built environment governance and management and institutions like land use change, ecosystem, the geography, the agricultural production, and livestock. So, in essence, all these factors affect an individual's or community's vulnerability through changes in exposure, sensitivity, adaptive capacity, and climate change. Now, how does climate change affect human health? So, here the first column is extreme heat, the poor outdoor air quality, the flooding, some vector-borne infectious diseases, the water-borne related infections, food-related infections, mental health and well-being. The climate drivers are in the next column, the exposure pathways, the next one, the health outcomes. So these three middle columns, the exposure, the climate drivers, the exposures, and the health, they are the individuals or communities' exposure to a health threat and the resulting change in the health outcome. The overall climate impact is in the last column, that is, the rising temperatures will lead to an increase in the heat related deaths and illnesses. The rising temperatures and wildfires, they would lead to increase in ozone and the particulate matter pollution. For example, the rising greenhouse gas concentration would result in increase in temperature, changes in precipitation, increase in frequency and intensity of extreme weather events, and these climate change impacts would endanger our health by affecting the air we breathe. So, climate change and air quality. As you know, weather plays a major role in the development, transport of pollutants, dispersion of pollutants, and deposition of air pollutants. Now, weather patterns, they can increase the urban heat islands, which can then lead to increase in pollution levels. Air pollution episodes are generally associated with slow, stationary, stagnant air masses. Changes in wind patterns can increase the long range transport of air pollutants. Air pollutants and fine particulate matter can also change in response to climate change. So, what are the effects of air pollution? The first one is the changes in the climate can affect the air we breathe, both outdoors as well as indoors. Increase in pollutant concentrations can have an impact on heat wave, ground level ozone concentrations, wildfires, and particularly human health. Increased UV radiation because of ozone layer depletion in the stratosphere, they will impact the human health and our ecosystems. Ocean acidification because of excess carbon dioxide, which is a greenhouse gas, it will affect marine life and our ecosystems. Airflow on the edges of a high pressure system, it can transport ozone precursors. And what are the ozone precursors? The VOCs, NOx. These are the two main precursors of ozone. Ozone levels are increasing in many areas of the world, and the climate driven increase in ozone will cause premature deaths, hospital admissions, lost school days, kids would not go to schools, people would not go to work, and acute respiratory symptoms like asthma, COPD. So here I am showing you the projected change in temperature, ozone, and ozone related premature deaths in 2030 by two different models. And this is a projected change in temperature, ozone, and the deaths by year 2030 by two different models, the two different global climate models, that is NCAR and by NASA, by using two greenhouse gas concentrations. So it is evident that air quality response to climate change will vary from region to region. This I am giving you from the US aspect, and these estimated show an increase in 1 to 4 degrees Celsius in daily maximum temperature, which would increase in 1 to 5 ppb increase in ozone concentration, and then tens to thousands of additional ozone related premature deaths per year. So climate change, increase in greenhouse gases, increase in temperature, increase in ozone concentration, which would lead to premature deaths. And this is by two different models for US. So global climate risk index, who suffers most from global climate change, and according to a very recent this year's report, Pakistan ranked 15th in the climate risk index based on 1995 to 2024. So it ranks 15th among different countries. So, in reference to heat wave in Pakistan, let me show you the Pakistan's climate change. Pakistan is offering a very grim case study of the potential consequences of climate change, with roughly about 32 million people displaced, more than 1,300 people killed, and nearly a third of the country was underwater following a 2022 monsoon season which was intensified by a climate change. And flooding has turned country's southern provinces into inland lakes, and it has destroyed more than 1.7 million homes, wiping out cotton and rice crops, and preventing farmers from planting fall wheat, which helps feed the population. So you remember heat wave in Pakistan, the 2022 heat wave in India and Pakistan, which is an extreme weather event which has resulted in the hottest March in the subcontinent since 1901. The hot season arrived quite early in the year and extended into April, affecting a large part of India's northwest and Pakistan. In that heat wave, about 90 people died. According to the USA Today, the death toll tops 1,150 in Pakistan's deadliest heat wave on record in 2015 during the beginning of Ramzan. And according to the Guardian in 2013, extreme temperatures that are commonly followed by floods, which are attributed to climate change. The maximum temperatures were about 51 to 52 degrees Celsius. The heat wave started on 12th May in Sindh province and gripped the entire country by 15th of May. In Lahore, it recorded 47 degrees Celsius on 23rd of May, its hottest temperature since 1954. In 2010, the May temperature in Mohenjo-daro reached 53.5 degrees Celsius, the fourth highest temperature ever recorded in the world and the highest ever in Asia. And now the temperature, I think in Pakistan, I have seen is somewhere around in 40s. So drought and food production in Pakistan, according to a recent report by United Nations Convention to combat desertification, Pakistan is listed among the 23 countries that are facing drought emergencies. Desertification control through sustainable land management, productive land is scarce in Pakistan, with 80% of the country being arid or semi-arid. Pakistan is one of the most affected country by the impact of climate change worldwide. It has a semi-arid climate, and it is prone to disasters such as floods, droughts, and earthquakes, all of which have adverse impacts on food security and livelihoods. The livelihoods of half of the population in Pakistan are dependent on agriculture, and some of the factors are around 60% of Pakistan's total population are facing food insecurity, 50% losses in exportable mango varieties, significant reduction in the per acre yield. 44% of children under 5 years of age are chronically malnourished. Population displacement due to insecurity and natural disasters has been a major humanitarian concern for the past several years. So, what are the conclusions? Uh, the global warming, which is underway, it will have health impacts for illnesses closely related to climate. Given the large and growing population, can controlling the global warming alone really solve the problem of climate related health impacts? And my answer is no. It is only half of the problem or less. So, what can we do? The adaptation, some prevention strategies. We need to control the emission of greenhouse gases. We need to reduce air pollution. We need to educate health professionals and the public. We need capacity buildings in this environmental health field. We need good, reliable data and research addressing key knowledge gaps in climate and health relationships. So, what are the technological solutions? We need to have in the industries the electrostatic precipitators. We need to have catalytic reduction in our cars. We need to have flue gas desulfurization systems in the industries. And most importantly, we need to capture carbon capturing all carbon dioxide. We need to reduce carbon emissions. So let me just tell you last month on April 2nd, I was fortunate to meet, I was honored to attend a meeting with the 2025 Chemistry Nobel Laureate Dr. Umar Yagi at our university at Albany. Let me briefly mention about him. He was born in Amman, Jordan in 1965 to a refugee family from Palestine. He grew up in household with many children in a single room with limited access to clean water without electricity. At the age of 15, he moved with his family to our area and he attended the Hudson Valley Community College and he was only 15 years old. At the age of 15, the university or the Hudson Valley Community College, they made objection and they said that you are very young, you cannot be enrolled as a student. So Dr. Umar got his associate degree, 2 years degree in chemistry from Hudson Valley Community College. And let me share one more thing here that Dr. Rauf Imam, he was an alumni of DJ Science College in Karachi. He was his chemistry instructor at Hudson Valley Community College. So after 2 years of degree from Hudson Valley Community College, he moved to our university at Albany. He got his bachelor's in chemistry from University at Albany. His work was in organometallic chemistry and applying organometallic chemistry to clean energy solutions including methane storage, carbon dioxide capturing, and water harvesting from desert air got the global recognition, and he got the Nobel Prize. So I'm taking one of his slides during his talk last month. Dr. Umar pointed out that climate change will cost $38 trillion per year by year 2049. His work has developed covalent organic frameworks COFs, which are advanced porous crystalline materials. This can be used in carbon capturing as highly efficient sponges to trap from ambient air or industrial sources. So, according to him, 100,000 tons of COF will capture zero point 0.5 gigatons of carbon dioxide, and this will cost $100 trillion worldwide. So, if we spend 4% of world GDP annually, we can capture this carbon dioxide in about 25 years. So that's about it. Thank you so much for your attention. Cleaner air, a safer climate, and better health start with the choices we make today. Thank you so much.
Thank you so much, sir, for such an informative lecture. And actually, this is also a need of time. Presently, we are facing a very high temperature in Karachi,
Yeah.
and with a very low quality air, very high index factor.
Yes. Yes.
Today, especially, the
Mhm.
I think there will be a higher temperature after 12
Mhm.
between 3 p.m.
Mhm.
So since the last 2 or 3 days or in coming 2 or 3 days,
Mhm.
there are the very critical time for for Karachi.
Mhm.
So this lecture will give us a very eye-opening data, which is very important at this stage.
Thank you so much. Any question?
Anybody have online student or any student interesting to ask any question, please. मेरे ख्याल में सर ये इतना अच्छी तरीके से आपने इतना इजी करके समझा दिया है कि ठीक है सर, थैंक यू वेरी
Thank you.
मच।
Thank you so much. Thank you very
स्पेशली
much.
आपका बड़ा और टाइम था। मैं आपसे इसकी एक दफ़ा और बहुत
नहीं नहीं नहीं,
शुक्रगुजार
नो
हूँ कि आपने
नो,
इसको अरेंज किया, मैनेज किया।
नो
और हम
प्रॉब्लम।
आपसे लिंक में रहेंगे, हमारे स्टूडेंट भी
Inshallah.
लिंक में रहेंगे। थैंक यू
Inshallah.
सर, थैंक यू वेरी मच।
My email is there. Anybody wants to have
श्योर,
any question, please send me
मैं
an email.
आई विल शेयर दैट email with all participants.
Okay.
Thank you, sir.
Thank you
For
very
you,
much.
good night.
Thank you. Good night. Yeah. Thank you so
Thank
much.
you, sir. Allah Hafiz.
Thank you.